In this video, we're going to look at the standard deviation, and the variance. And these are two measures of spread, and these two are often linked together, and you'll see why by the end of this video. What these tell us is how far our data deviates from the mean. And what I mean by that is how far spread out the data is either side of the mean. So say we have a piece of data in a histogram that looks something like this. And here's the mean somewhere here. This is not very spread out because we've got a frequency of something or other over here and something or other over here, but it's not very far to travel from the mean. So this doesn't deviate very far either side. But if we had a piece of data like this in a histogram, with data all over the place like this, and we had a mean over here, then this deviates a lot because a point over here is quite far away from our mean over here, and the point over here is quite far away from our mean. So this has quite a high standard deviation, and this has quite a low standard deviation because it's all bunched up together, the data, and this is all spread out. The formula for working out the variance, how far this stuff is spread out, looks a bit big and scary, but it's not too bad once you know what you're doing. And it looks like this. The sum of, which is sometimes they use a sigma for, like this, x minus the mean of x squared over n minus 1. And that looks a little bit full on, but I'll break it down for you by doing an example. Here is a small set of data that I'm going to work out the standard deviation and variance for. Now what I've just done is put it in a table here so I can show you how this calculation works. Now remember, the formula looks like this. The variance is going to be equal to the sum of x minus the mean of x squared over n minus 1. So what we notice is we need to find the mean of x in here first. So how do I find the mean of these numbers? Well, I add them up and divide by how many there are. So in the calculator, I'm going to do 12 plus 18 plus 20 plus 11 plus 17 plus 12, and then divided by 1, 2, 3, 4, 6. And that is 15. So the mean is 15. Now what I want to find out is how far each of these points deviates from my mean. So I want to know the deviation, which I find out by saying x minus the mean of x. In other words, how far away from the mean is this point? So our mean is 15. So on a histogram, say 15 is here. I've got a frequency, some data over here at 12. I want to know how far away it is. So I say 12 minus 15, and that's negative 3. So it's down 3 away from 15. 18 minus 15, that's positive 3, because that's 3 upwards from 15. Now I say 20 minus 15, and I get 5, and so on. Now because some of these are above the mean and some of them are below the mean, I've got some negative numbers and some positive numbers. But what you'll notice is they'll all cancel each other out and become 0, because I've got negative 3 plus 3 is 0, plus 5 we're up to 5, minus another 4 we're up to 1, plus another 2 we're up to 3, minus another 3 we're back to 0. And what's going to happen here is these are all going to add up to 0 if we've done this right, because they should all deviate the same amount. Like that's how we get the mean. These deviations will all add up to 0, and we'll sort of come back to this balance point in the middle of the weight here. So to get rid of this, because if everything adds up to 0, we can't really do much with it, can we? So what we do is we square them, because squaring things gets rid of the negative sign. Because if I have negative 3 times negative 3, what happens with two negatives? It becomes a positive. So I get positive 9. And the same thing with positive 3. If I have 3 times 3, I get 9. And so here we have a negative 4. Well, a negative times a negative is a positive. So every time I square these things, they become positive. So this one here, I'm going to do the deviation, which is this x minus x squared, x minus the mean of x squared, and that'll make these positive numbers. So negative 3 squared is 9, 3 squared is 9, 5 squared is 25, negative 4 squared is positive 16, 2 squared is 4, and negative 3 squared is positive 9. Now I can do this top part of the equation over here because I know what the sum of these x minus the mean of x squareds is by adding these up. So I want 9 plus 25 plus 16 plus 4 plus 9. And that is 72. So the top part of my equation here to figure out what the variance is going to be equal to is 72. And the bottom part is n minus 1. Now, n is the number of observations there are, the number of data points. So we've got 1, 2, 3, 4, 5, 6 of them. So I say 72 over 6 minus 1, which is 72 divided by 5. And that is 14.4. And that is the variance. Now remember I said how variance and standard deviation are linked? The reason is because the standard deviation is just the square root of the variance. Standard deviation. So once I know this, 14.4, all I need to do is the square root of it and I get the standard deviation. So I do that on my calculator and I get 3.79. And that is the standard deviation. That's it there. So we're talking about the variance and the standard deviation combined, which basically tell us how far things are away from the mean in either direction. And if we have a big standard deviation, then it means it's really spread out, and a smaller standard deviation will mean they're quite bunched up, they're quite close together either side of that mean. Now for some good news. You hardly ever need to work out variance and standard deviation manually the way I just did in that table. In fact, I haven't seen a question like that come up on an exam in recent memory. I can't recall one at all, in fact. The reason I showed you that table is so that you understand what variance and standard deviation tell us. They're talking about deviation either side of a mean, and being bunched up means we'll have a small one, and being really spread out means we'll have a large one. Because that concept they will test you on in the exam by asking you it in different ways. But you don't really need to do that maths that I just did in that table very often. So how do you work it out instead? The answer is on your calculator. So in the lists, you put those numbers in, so 12, 10, 18, etc., 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 and then you say, please tell me what the standard deviation of these numbers is. Now, depending on what model your calculator is, that'll be done differently. So ask your teacher how that works if you don't know what the calculator steps are. One of the most important things to understand about the standard deviation and the variance is that the standard deviation is equal to the square root of the variance. Because this little piece of information right here, this handy little thing, can come up in a multiple choice exam quite often, asked in a bunch of different ways. So for example, they might tell you what the variance is and ask you as a result what is the standard deviation, or they might tell you what the standard deviation is and ask you as a result what the variance is. Because once you know one, knowing that they have this relationship with each other, you can work out what the other one is. So say I told you that the variance was 25 and I asked you what the standard deviation was. Well, you'd say the standard deviation is the square root of the variance, which happens to be 25. So the standard deviation is equal to 5. Now say, let's go the other way around. Say I told you that the standard deviation was 4, for example, and I asked you what the variance was. So if you know that the S is 4 and you know that you're trying to find out the square root, you're trying to find out the variance, which is the square root, I just inverse this. I do the opposite of square rooting, which is to square it. So if I say 4 squared, I get the variance. So 4 squared is 16. So that would be what the variance is in that case. So knowing that they have this relationship is a very handy little piece of information, because they'll ask questions to do with this rule in a bunch of different ways on the exam. So once you know this, you've got a handy little tool to have in your back pocket, and you can be sure that they'll ask you something about this on the exam.